Hello friends, welcome to engineering tutorial. Now in my previous video related to common emitter configuration or connection of BJT, I discussed about the basic concepts related to common emitter connection, the basic parameters such as the current amplification factor beta and the expression for collector current for a common emitter configuration of BJT. Now as I said in this video, I will be discussing about the voltage current characteristics of common emitter connection, BJT connection. So as you all know, the voltage current characteristics of a BJT connection is studied in two ways, divided into two categories. First, the input characteristics and the output characteristics. So we'll be discussing them separately. So the input characteristics is a curve which is plotted between the input current and the input voltage at constant output voltage. It is the basic definition of input characteristics. In case of the common emitter connection, in case of the common emitter connection, as you can see here, the input current is IB and the input voltage is VBE, base emitter voltage, this one and this side. The output current is collector current IC and the output voltage is VCE, this side towards the right. So this is all about the input and output currents and voltages. Now, so the input characteristics for the common emitter configuration will be plotted between the input current, that is the base current, and the input voltage, that is the base emitter voltage, at constant output voltage, that is the collector emitter voltage. So here this is the input characteristic curve for a common emitter configuration BJT, where the base emitter voltage, that is the input voltage, is in the x-axis and the input current IB is in the y-axis. Now this characteristic curve is very similar to that of the characteristics, VI characteristics of a forward bias diode. Because the common emitter configuration of NPN transistor is similar to that of a forward bias diode. So here, as you see, up to 0.7 volt of VBE or base emitter voltage, there is actually no base current or no input current. But suddenly when it approaches the 0.7 volt mark and when the base emitter voltage is increased beyond that, there is a sharp increase in the base current with respect to the base emitter voltage. Now this voltage is sometimes called the cut-in voltage of the diode, but here it is also called as the cut-in voltage. Now it is 0.7 volt for silicon transistors or BJT. If it had been a germanium transistor, it would have been 0.3 volt. So here we have drawn the characteristics for various collector emitter voltage, that is for VCE 10 volt and VCE 1 volt. So you'll find that this cut-in voltage is more or less close to 0.7 volt. In this case it is 0.68 or 0.65, but nearly around 0.7 volt. Another thing is that this variation of current with respect to voltage is slightly less as compared to common base configuration. So in case of the common emitter configuration, the resistance or the input resistance is higher as compared to the common base circuit. Now I have mentioned input resistance, so we must first understand what the input resistance is. The basic definition of input resistance is the ratio between a small change in input voltage to a small change in the resulting change in input current at constant output voltage. So in case of the common emitter configuration, it is the ratio between the base emitter voltage, which is the input voltage, to the change in base current, which is the input current, at constant collector emitter voltage, which is the output voltage. Okay, so the mathematical uh, uh, formula of input resistance for common emitter configuration is delta VBE by delta IB at constant VCE. Normally, the input resistance is of the order of few hundred ohms for common emitter configuration, and it is higher as compared to the common base configuration. Okay, so this is the input resistance and input characteristics of common emitter configuration. Next is the output characteristics. So the basic definition of output characteristics is that it is a curve which is plotted between the output current and the output voltage at constant input current. Okay, not at constant input voltage. It is a common mistake which is done by several students, is that they write the definition of output characteristics as the curve plotted between output current and output voltage at constant input voltage. It's not that, it's constant input current. So here in case of common emitter configuration, the output current is the collector current, the output voltage is the collector emitter voltage. So this will be a plot between the collector current at collector emitter voltage at constant base current, which is the input current for common emitter configuration BJT. So this is the plot or the curve VI characteristics. Okay, so here the collector emitter voltage or the output voltage is in the x-axis, and the collector current or the output current is in the y-axis. So here for various values of base current, one thing is common, is that the collector current after a certain collector emitter voltage, upon reaching a certain value of collector emitter voltage, they become constant and become independent of the collector emitter voltage. Now that value or voltage of collector emitter voltage is called as the knee voltage. Okay, so this up to this knee voltage, the collector current, it shows some change with respect to variation in collector emitter voltage up to this knee voltage. This knee voltage, these are the knee voltages for various plots. Now when this voltage, the collector emitter voltage is increased beyond that knee voltage value, this collector current becomes constant and becomes independent of the collector emitter voltage. Now the knee voltage is normally lies around 1 volt. Here I have drawn it in magnified way, but it's very close. Okay, it's very close. I have drawn, for the sake of clarity, I have drawn it with some space, but normally it lies very close to each other, and the knee voltage is around 1 volt. So the knee voltage is about around 1 volt, and we can define knee voltage as that value of collector emitter voltage beyond which the collector current attains a constant value and becomes independent of the collector emitter voltage, because regardless of how much we increase the collector emitter voltage, the collector current will remain the same, and that knee voltage value always lies around 1 volt. So this is the output characteristics. Okay, so the basic summary of the output characteristics is that up to the knee voltage, the collector current shows variation with respect to collector emitter voltage. Beyond knee voltage, the collector current acquires a constant value. Now the transistor is always operated in the region beyond the knee voltage. Okay, it's always operated in that region, and in that region the output collector current is given by the formula IC is equal to beta IB. Beta is the current amplification factor. Beyond this, always in this flat line region, the transistor is operated, and this region, the value of this collector current is equal to beta IB. So here, as we increase beta, the value of the constant collector current also increases. You see, when we keep on increasing beta value, the constant input current IB value, the value of the constant value of collector current also keeps on increasing from 1 to 2 to 3 to 4, because of the formula IC is equal to beta IB, where beta is the current amplification factor. Okay, so here the same things I have noted down. You can note it if you want. Okay, so now the important thing related to output characteristics is the output resistance. The same basic definition. It is the ratio between the change in output voltage, which is the collector emitter voltage, and the change in output current, which is the collector current, at constant input current, which is the base current, for a common emitter configuration BJT. So the output resistance is mathematically written as delta VCE by delta IC at constant IB. Now the output resistance, we know it's very high normally for BJTs because of the reverse bias. Now for the common emitter circuit, the output resistance is less as compared to the common base circuit, and normally lies around about 50 kilo ohm, okay, for common emitter circuit, and its resistance is less than that of common base circuit. So here we have discussed the input and output characteristics of common emitter configuration BJT. Now in my next video, I will be discussing about the common collector configuration of bipolar junction transistors. The same thing, the basic parameters and voltage current characteristics. So I hope you like this video. Please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.